Hey Chem Stars, it's Ms. McCauley. We're going to be going over Chapter 2 Practice, pages 17, 18, and 19 today. It's all about significant figures in measurements. In chemistry, we also call these sig figs, to abbreviate. Okay, so a measurement can only be as accurate and precise as the instrument that produces it. A scientist must be able to express the accuracy of a number, not just its numerical value. You can determine the accuracy of a number by the significant figures it contains. Now, at first you're going to be confused. It's a lot of new rules and it doesn't work like it does in math class. So stick with me. We're going to work through these problems, and I know that it will be confusing at first, but after you do some practice, it should start to get clearer. So here are the rules for significant figures. All digits 1 through 9 are inclusive, are significant. Okay? So 129 has 3 significant figures. If you look at it, there are 3 place values here, and they're all holding important data. Now the next step is that zeros, so that's pretty clear. Things get weird though when we come to the zeros. So we have 4 rules that all deal with zeros. So zeros between significant digits are always significant. So for example, the number 5007, there's 1, 2, 3, 4 sig figs here. So we are sure about the thousands. We're sure about the hundreds, the tens, and the ones. All those place values are holding information that's important. Now, trailing zeros in a number are only significant if the number contains a decimal point. So I kind of wrote this another way over on the side. So when you're looking at these trailing zeros, is the zero really necessary? If no, and you wouldn't normally write it in math class, then the person wrote those zeros for a reason, and please count it as a sig fig. So for example, we have 100.0 and 100. Now in math class, they all have the same. But is that last zero really necessary? No, someone wrote it for a reason. So this number, 100.0, it has 1, 2, 3, 4 sig figs. And we know that the hundreds, the tens, the ones, and the tenths, we're certain about the values in all those digits. But now the number 100, you might think it has 3 sig figs. It only actually has 1. We're going to go through some practice problems and figure out why. Okay, now this is where zeros get even weirder. Zeros in the beginning of a number whose only function is to place a decimal are not significant. So these are like your kind of your placeholders. It's not all placeholders, it's a certain type of placeholders. So the number 0.0025 only has 2 sig figs. So for the example, this one, we have 3 sig figs. See how they put that 0 at the end? They really need to know, but that goes back to our trailing zero rule. And now this number has 5 sig figs, okay? So every time we've got to go back to those 5 rules, and with more practice, it'll get easier. Now I'm going to be honest, I've never learned these 5 zero rules. Instead, I have a little saying I say to myself. So I say, if the decimal is present, so P for present, begin counting at the first non-zero from the Pacific side. Okay, so if we're looking at any number, if we can see a present decimal, we're going to count from the Pacific. That's the left, okay? I didn't say left because we have that present Pacific alliteration. Now, if the decimal is absent, begin counting from the first non-zero from the Atlantic side. So we have absent, Atlantic, present, Pacific. Now Atlantic, that means count from the right, okay? If you can't remember left is Pacific and right is Atlantic, I have those up above the SMART board in the front of the room on the wall. So you either have to memorize these 5 zero rules and apply them every time, or memorize this little poem here. You'll get the exact same results doing it either way. Okay, so let's go through some problems. Determine the number of sig figs in the following numbers. So I'm going to do Pacific, Atlantic, So present decimal, count from the Pacific. First non-zero. No. 1 sig fig. Present Pacific, first non-zero, 2 sig figs. See how these numbers are different? They wrote that 0 for a reason. Okay, I'm going to try and do Atlantic in blue. Absent, count from the Atlantic. 1, 2, 3 sig figs. Present, count from the Pacific. 1, 2, 3, 4 sig figs. Absent, count from the Atlantic. So these are all placeholders. There's only 1 sig fig in that number. Okay, let's come over here. Present, count from the Pacific. That decimal makes that this number has 4 sig figs. See how 5,000 and 5,000 point are different? Okay, present, count from the Pacific. 1, 2, 3, 4, 5, 6 sig figs. Present, count from the first non-zero on the Pacific. Only 1 sig fig in that number. I know this is the one you're not going to like, but that's the sig fig rule. Number 9, present, count from the Pacific. That's a placeholder. Doesn't count. 1, 2, 3, 4 sig figs. Absent, count from the Atlantic. 1, 2, 3, 4, 5. Okay. If you don't like my Pacific Atlantic, pause the video, go back up to your 5-0 rules and apply them. You will get the same answers. Okay. Now, determine the location of the last sig fig by placing a circle on that digit. Okay. So, for example, if we have a present decimal, we're going to start counting from this way. That's our last sig fig. If we have an absent decimal, we're counting from this side. Now you're like, oh, well, that one's last. Well, okay, we're reading it backwards for sig figs. We want the smallest place value. So thousands or hundreds, the hundreds are the last significant place value. Here we have thousands, hundreds, tens, and ones. The ones is the smallest significant place value. Okay, so this one, we know the 0 is not significant because we're counting from this direction. So that 0 is not significant. We are sure about the tens. Here, the smallest place value. Here. Now, don't worry when you see scientific notation. Just focus on the coefficient. So here we have the ones, tenths, hundreds, thousandths. That's fine. Here's our smallest sig fig. Okay, now this one we gotta be careful. There's no decimal. So these aren't sig figs. They don't count. We're counting from the Atlantic. Here are my 3 sig figs. What's the smallest place value that holds information? Let's see, the 10,000s, the thousands, or the hundreds. Okay, here it's pretty clear. Here we're pretty clear. This one, don't worry. Just look for the smallest number if it's in scientific, and then here. Okay, this part might have been tricky for you. That's okay. If you're not sure, try this part by going up and counting sig figs first. Okay, next page. So I'm going to go through and talk through maybe the first 5 or 6 in depth. Then I'm going to give you a chance to pause the video and come back and check your work. So let's start here. For each of the following, write the number of sig figs. Okay, so here we're absent. Count from the Atlantic, the first non-zero, 3 sig figs. Absent, count from the Atlantic, these don't count, 3 sig figs. Oh, this one we're present, we're counting from the Pacific, 3 sig figs. 3 sig figs. These are all placeholders, 3 sig figs. These zeros were written for a reason, okay? You wouldn't normally need them in math class, so they're telling us there's important data in those digits. So we've got 1, 2, 3, 4, 5 sig figs. Anytime there's a 0 sandwiched in the middle, it always counts as important. So there's 4 sig figs, 3 sig figs. Now here we gotta be a little careful. There's no decimal point. So we count from the first non-zero on the Atlantic. Those are placeholders. We're only sure about the thousands and the hundreds here. Okay. Let's see. Present, Pacific, 1, 2, 3. That 0 is significant. These are placeholders, 2 sig figs. Once you start counting, so if you decimal's present, begin counting from the first non-zero on the Pacific side, and once you start counting, you must keep counting, okay? So those zeros are written for a reason, to tell you we're sure about those place values. So we've got 1, 2, 3, 4, 5 sig figs. These are placeholders, 1, 2, 3, 4 sig figs. Present, count from the Pacific, the first non-zero. Once you start counting, you must keep counting. Anytime there's a sandwich 0, it counts. Okay, now this one, what do you think? Do those zeros count? Decimals present, begin counting from the Pacific at the first non-zero. Those are all placeholders, only 2 sig figs in this number. Now this is one I know you're not going to like. Like, well, how can we measure those place values without being sure about those ones? I know, but that's the rule. Just go with it, please. Okay, 1, 2, 3, 4. Now this one, absent Atlantic, count from the first non-zero, so not really counting from that direction. There's 3 sig figs, 5 sig figs, 3.00 on this very bottom one here. So let's see, 1, 2, 3, 3 sig figs. Okay, so I went through this kind of fast, trying to summarize the rule. I'm gonna ask you to pause the video, and then we're gonna come back and check your work. So try the next columns. It's okay to get some wrong right now. We're all learning and trying to figure it out together. Okay, Chem Stars, so let's scroll through that middle column. Okay, if you need to pause the video, please do. So take a look through. See how 9 and 90 have the same number of sig figs here? Because that 0 is just a placeholder. Now, what if I put the number, let's say if I had written 90 point. Well, now that would give me 2 sig figs. See how the number 90 period is more certain than 90? Okay, keep scrolling through, see how you did. Remember, if you need to, pause the video. Okay, so I'm hoping that you did, pretty well, fair to okay-ish. I'm going to go through that last column with you, so hopefully we can clarify some more sig fig problems. Okay, 41, decimals present, count from the first non-zero on the Pacific. These are all placeholders. Once you start counting, keep counting. 1, 2, 3, 4, 5. Absent, count from the first non-zero on the Atlantic. That means that these are all placeholders, 2 sig figs. Absent, count from the Atlantic from the first non-zero, 1, 2, 3, 4, 5, 6. So let's look at the big difference between these two numbers. This number, we have information in the ones place value, so we know that they were certain about the ones, and if you're certain about the ones and the hundreds of thousands, you are measuring all the digits in between. But this number, we only can tell that they were certain about the hundreds and tens of thousands. Everything else could be an approximate rounded number. Okay, number 44. Oops. Number 44. So present, count from the first non-zero in the Pacific. 1, 2, 3, 4, 5. These are placeholders. Absent, count from the first non-zero in the Atlantic. Those are placeholders. This one's sneaky. These are all placeholders, only 1 sig fig. Compare it to the next one. Now, placeholder, but this counts. 1, 2, 3, 4, 5, 6. I know you won't like those two, but it's okay. Just trust me. Go with the sig fig rules on this. Okay, 1, 2, 3, 4, 5, 6, 7. That 0 was written for a reason. Ooh, this one. No decimal. Count from the first non-zero in the Atlantic. Only 1 sig fig there. Absent. Count from the first non-zero. Those are placeholders. 1, 2, 3, 4, 5, 6. Remember, any sandwich 0, it counts. Once you start counting, you must keep counting. Okay, absent, so 2. Absent, there's 3, that's 0 at sandwich. Now present, count from the Pacific. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Absent, count from this side. First non-zero, only 2. Another absent, only 1 sig fig. That's like 500-ish. This 500 could be anywhere from 450 to 540. All rounds to 500. Present, that's a placeholder. Count from the Pacific. There's 3. Absent, count from the Atlantic. Okay, so take some time. Go through these. If you're not sure about one, try and do some more research. Go back to your 5-0 rules and look at how they apply. Try the Pacific and Atlantic poem. I don't care which way you use to figure out your sig figs, you'll get the same answers each time. We got one more page. We're actually going to start applying the sig figs here. So we've already done some reading tools. Now remember, it's always going to be what you can read plus 1 digit that you estimate. Okay, so this one, we can read the ones. So on this first ruler, you can read the ones. So we're going to guess the tenths, okay? So this is about 9. I'm going to call this 8.9 centimeters. And you can see there's 2 sig figs. So I read 1 sig fig and I guessed the second sig fig. Now my next reading, here I can read up to the tenths. Oops, tenths. That means you're going to guess to the 100ths place value. So I can read right here, it's between 8.9 and 9.0, okay? So if I'm between 8.9 and 9.0, right? I'm going to guess this is maybe 8.95 centimeters. 1, 2, 3. There's 3 sig figs. So you see how my measurements are different? The rulers are different. There's a higher degree of certainty in my second ruler. Even though these are all right around 9, the arrow's really in the same place, this is my more accurate and my more precise ruler. Okay, how about number 3? Now on this one, be careful. You can read the tens. That means you're going to guess only the ones place value. Okay, so I'm going to go, okay, let's see, 135, 1, 2, 3, 4, ooh. Okay, it's probably more like 133-ish. So I'm going to say approximately 133. You can say plus or minus 1 on that. Okay, there are 3 sig figs. I was reading the hundreds and the tens, and I guessed the ones place. There's always going to be one more sig fig than you could read on your ruler. Now, how about this next one? We can read the thousands, the hundreds, the tens. This one, we're also going to be guessing the ones. Okay, so 20, 30, here's the 5. We're between the 5 and the 6. Oh, and that was dumb. You can read the ones here, can't you? Here's 2, 2, 2, 1, 2, 3, 4, 5, 6. So here you can read the ones. You're going to be guessing the tenths. Always check your scale before you start saying things. So I'm between 5 and 6, or is it like 0.5? So it's 2, 2, 2, 5.6. How many sig figs? 1, 2, 3, 4. There's 4 you can read off of the ruler, and you guess that 5th sig fig. Okay, now let's be careful on this one. Okay, here's 110, here's 120. So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This one, same thing. We can read the ones. We're going to guess the tenths place value. So 11, 12, 13, here is 114, here is 115. So our number is going to be 114 point something. Now, I'm not going to say 0.5. It looks too close to be 0.5. Maybe 0.2. If you want to tell me 114.3, 114.4, I'd be okay with any of those. So how many sig figs? 1, 2, 3, 4. I could read 3, and I'm guessing the 4th. Okay, just a couple more on this one. Ooh, boy, this one's different. 1100, 1200. So I can read the thousands, and I can read the hundreds. Can I read the tens here? No. Here I'm going to be guessing the tens. So let's see. This would probably be around 50. Let's see. 1, 10, 20, 30, 40. Ooh, my scale's kind of off here. Oh, let's say maybe that's the 20. So we're going to say 11, 20. That's what I read. This is what I guessed. And there's only 3 sig figs this time. See how there was 2 here in my numbers? Then I'm going to be guessing the 3rd. Okay, 2 problems left. Okay, ooh, a lot more precise now. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so there's 10 lines here. So we're actually reading the hundredths, and every tenth is marked. So this right here is 0.05. This is 0.06, and this is 0.07. So I'm right between 0.06 and 0.07. So what do you think, 0.065? I think that sounds pretty good. Only 2 sig figs in that measurement though, because I was guessing that place value. These are all your placeholders. Ooh, okay, we got some more tricky ones here. We gotta count real carefully. So this, let's see, 1, 2, 3, 4, 5. On the ruler right here, I can read 0.025. This is 0.026. So on this ruler, I'm reading the tenths, the hundreds, and the thousands. So that means I'm going to be guessing the 10,000th place value. So you're like, oh, but look, it's right on that line. Isn't it just 0.026? It's right on the line. But we are certain it's on the line. So what do? We add a 0 at the end. Okay? I know this is different than how you normally read rulers. Just stick with it. Keep practicing. Go back to those 0 rules. And the more you practice, the better you'll get at sig figs. Okay? So remember, don't